everyone. Welcome to the Excel overview from Chapter 4 of Investments. So the first tab we're going to look at is growth. So in this growth tab, we have below the prices for the first and last day for Netflix. So here is first day and last day for Netflix from year 2014 to 2015. So this just means the first day of the year the stock was at 52, and the last day of the year, say December 31st, was at 48.80. So we need to calculate the return for each year. Okay, so that's pretty easy. When you calculate a return, what you want to do is, I always say, new minus old divided by old. So that means here is, I would take, I'm going to start my equals, parentheses, new, the newest price, minus the older price, divided by the older price. So, and then we'd get a return of a negative 6.87%. And I can actually just pull this down to get the return. So the biggest year here was 2015 with 132% return. So if I want to calculate the average, I could just use the average function, and it pops up there. And then I just highlight the 4 cells, close parentheses, and it's going to create just a straight average of a return. But I want to actually calculate the growth rate. So the annual growth rate. So I could calculate that by first entering. I could use a growth rate formula where I'm going to put let's try E19 divided by D16. So the first and last day there, close parentheses, and I'm going to escalate that into an exponent. And since I have 4 years, it would be to the 1/2 exponent. 1/4, exponent. And if it was 5 years of data, no, don't. And let me put parentheses around this since I'm doing a division in there. And then I'm going to finally -1. So this would be a growth formula here, and this would measure give me a average annual growth, which is a more accurate growth of the stock than the average. So that's how you would calculate the returns for the year, the average annual returns, and then the average annual return growth rate. Okay, so let's go to the holding period return, the HPR. So calculate 1 year holding period return for the following 2 investment alternatives. Which investment would you prefer, assuming equal risk? Okay, so here, what we can do is going to calculate these 2 investments. Okay, so the capital gain, this is pretty simple. We're just going to take the end of the year minus the beginning of the year. So we have a $5 capital gain here, and here we have a $0 capital gain. Now, as far as the holding period return in dollars, let's look at, first we should calculate a sum, and we're going to sum all of the quarterly, I guess these would be dividends, and then we're going to add the capital gain. So, why do we have a spill here? Okay, that helps. I just didn't put the sum in the formula, but there's the formula there. Then the holding period return, we simply just take D29, and we're going to divide that by D26, which is the beginning value. So that gives us a 35% return. So we're going to do this over here. The holding period return, again, would be that same formula where I want the sum formula. Let me click it this time. I'm going to highlight all of the capital gain, the dividends, and then I'm going to add to that the capital gains. So we get $8 here. And if I take the $8 and I divide that by the beginning price of the year and it's a 14% return here. Okay, so that's how you calculate the holding period return in dollars, which is dividends plus capital gains, and then the holding period return percentage. Okay, so let's move into internal rate of return. We use a financial calculator, so we're not going to, no one uses financial calculators. That's just an old textbook thing. So we're going to say, use an Excel spreadsheet to estimate the internal rate of return for the following investments. So we have investment A and investment B. So here's the initial investment and then the income. So if we look at the cash flow down here, we're just, year 0 is a negative cash flow because we're paying for the investment. So the cash is flowing out from our cash into the investment. And then we have years 1 through 5 is the income that it's generating. So if we want to calculate the internal rate of return, it's going to be a fairly simple calculation here. We're just going to select, I'm going to say equals internal rate of return. Parentheses, I'm going to highlight this whole group here, close parentheses. And then I get a 14% internal rate of return. Now I could actually just pull this over here to just push the formula over here, or if you want me to see it, show me calculating again internal rate of return, close parentheses, highlight this group, and then we get that 1536. So the internal rate of return is higher in investment B, so investment B should be the investment you want to invest in because you get a bigger rate of return than investment A. Okay, let's look at net present value. So we're going to calculate net present value and internal rate of return as well. So here we have an investment. We have an investment generates the following income for 2020 to the end of 2026. Okay, $2,200. Estimate the internal rate of return. If a minimum return of 5% was required, would you recommend the investment? Okay, so here's the income streams. Here are the years. So it tells us that we have initial purchase price of the investment at $200. So this is really year 0 here. We pay the $2,000 investment. We have the cash flows are from here. So the cash flows are just copied in here. And then 2026, we have the sale price at the end of 2026 as $2,200 plus the 20. So that's how you get to 2,220 right here, adding those two together. Okay, so here we go. These are our income flows from this investment stream. So the internal rate of return percentage, again, equals internal rate of return. Select that function. And let me go back on this. And then what we're going to do is we're going to grab this whole column of these cash flows. And that's it. So 5.242% would be the internal rate of return. Now the net present value. Now the internal rate of return, we're going to calculate as well. So I'm going to say equals net present value function. And then it's going to be the rate. You see a little Q down here. We have the rate, which is going to be 5%. I'm going to put a comma there. And then the values are going to be D20 to D27. Put those values in there. Close parentheses. And we get $46.62. Let me show you an alternative way to calculate it if you don't know the functions that well. You can go to, under formulas, insert function, and you can type in internal rate of return. Double click on that, and you'll get this formula builder. So in this formula builder, where it says values, you just have to highlight the values, then click done. And then we'll put this in a percent. Move it to decimals so we get the same exact number. Now if we want to do net present value, again, net present value, double click on that. And this might be easier, sometimes easier to build. We know that it's a 5% rate, so I put in a rate of 5%. And then the values here, I could click each value, 2,000 here, 140 here, and then I can keep doing that, just adding all the values. But Or alternatively, you can just highlight the whole stream and then hit done, and you see you get the same amount. So those are just two ways that you could calculate those same two numbers. Whichever, when you're a little bit quicker, you know the function's better, you can do the equals IRR and then start inputting the formula. But if you're not sure about the formula, this formula builder is a good way of getting that done. Okay, so let's go to standard deviation. Okay, so we have two stocks here under the standard deviation. We have stock A and stock B with different returns for each of these years. So we want to know, just looking at these, which seems riskier? And if you're just looking at these, you could probably say A is riskier because we have a bigger variation. Some years it's only 1 or 4% return, some years 26% return. But under stock B, the returns are much more reliable. So we could just say, since they both have the same average return, B seems a lot more consistent and stable and safe. But let's prove that out using standard deviation to figure out a measure of risk. So first we want to find the average here. I mean, they are telling the average here is 12%, but we'll just throw in a formula here, the average formula. And we'll just highlight that range, close parentheses, and that's the average there. And I can do the same over here. And I could drag this over here to calculate it, get that same formula. Or you can just, if you want to do it from scratch, you get 12% on both sides. Now the standard deviation, again, I just use this Excel standard deviation, but I'm using standard dev S. I'm going to highlight the 5 years of returns and get the standard deviation for stock A. Stock B, standard deviation S, highlight these, and we'll get the two standard deviations. So clearly, this higher standard deviation denotes a higher variance of returns and a higher risk. So stock A, like we thought, is riskier. Okay. So let's move into this problem. This is a little bit more complex of a problem here. Okay, so in this problem, we have some information here. We have 2012 to 2017. We have the stock price, the dividend. This is for IBM, and for HP, we have the stock price of the dividend, and then we have the value of the S&P 500. So part one, here we want to calculate the holding period returns for each of these stocks for each year. So let's start with, I see here that this is already calculated for us. I can easily just take this and bring it over like that to calculate all the returns. But let's look a little bit more closely. How is this being calculated? The formula's in there. So we would say F7. So F7, which is the dividend, we're going to add that to F6, which is the price, minus E6, which is last year's price, divided by E6. So that's the basic formula for calculating the holding period returns for IBM, HP, and the S&P 500 for the 5 years, and then we're just throwing in an average formula here like we've seen on the other page for each of these stocks. So now they calculate the standard deviation using something similar to how they map it out in the book. So here we're going to do, this is for IBM, and we want to do the returns for IBM. So I'm going to go up here. Here are the returns for IBM. So I'm going to actually highlight these. And I'm going to copy this. And then here I'm going to do a tricky thing. I'm going to do a paste special. So I'm going to go paste special. And then I'm going to get this paste special box. I'm going to transpose. And you see, you get this reference. So what I'm going to do is I'm going to paste special. I'm going to transpose, but I'm going to bring in just the values. The values in number formats I'm going to bring in, not the formulas. So that way I lose the formulas. That way it won't get those hashtag references. So it's just an easy way to go from horizontal to vertical in a copy. Now the average is going to be equal to, we calculate the average here. So we'll just put that down. Then if I do an absolute on this by hitting F4 or putting a dollar sign in front of the I and the 29, then I can just easily carry this down. Okay, so here what we have in this bar 3, it's saying column 1 minus column 2. So negative 0.15 minus negative 0.57, we get 0.4. So this is just 1 minus 2. So this is just 1 minus 2 in this. And then here, we're taking the result here, which is 1 minus 2, and this makes it a little bigger. It's probably better. And then we're just bringing it to the exponent of 2. So in this you see we're taking the F41 to the exponent of 2, and then we're finding the sum of this column here. So if I delete this and I just do sum, I get that sum of that column. Now, to calculate the variance, I'm going to use an Excel formula to calculate the variance. So I'm going to use equal var S, and I'm going to highlight D41 to D45. Close parentheses, and I get a variance of 2.23. Now, standard deviation is going to be something similar to what we did before, equals standard div S, S for statistics, that's what I'm going to say, and I highlight the same D1 to D45, and I'll calculate the standard deviation. I must have hit an extra. Let me try that again. Yeah, I had an extra. There we go. Okay, so that's standard deviation for IBM. And then we'd follow that same path for calculating it in here, where we go, we take our returns, copy, paste special, values and formats, transpose, okay. Then we would say equal the average, and I put absolutes, which are just dollar signs in front of the position, so I could copy this down. And I can actually just take these formulas here and copy them here, because it's gonna know to slide the cells down the same amount of rows. And then for the last one, the S&P 500, let me copy that, paste special, so you can't see, I'll show you in a second, but here, values and numbers and transpose, okay. What you might not be seeing is when I go paste special, I'm going all the way down here and clicking this paste special. And that's when the dialog box comes up. Okay. So I'm going to say equal F4. Put this down. And I'm going to copy this down here. Rather than redoing the formulas, this is just a lot simpler. So then you'd want to analyze this. The standard deviation is 11, and the variance is 1 on the S&P. For HP, it's 36 and with a 13, and here we got a 14 with a 2.2. So it would look like the S&P 500 was the lowest level of risk. Okay, so that'd be a way of looking at these different stocks and kind of trying to use the standard deviation, an idea of the risks, and since they have different average returns, it's really the variance that would tell us the risk more succinctly. So we would see the lowest risk is the S&P 500 because it has the lowest variance, because the standard deviations aren't really comparable because they have different average returns. So the safest investments out of all of these would be, of course, the S&P 500 with the lowest standard deviation and the lowest variance, then IBM, then HP. And you can see that the returns for HP are a lot more aggressive. Okay, so let's move into some more. Okay, so let me delete these. Unfortunately, I just did this whole, recorded this, but I forgot to press record, so I'm going to do it again for a second time. So here what I'm doing is we're doing future value, and we're given A through F investments, so these initial investments, the rate of return, and the number of years we're investing. So these are simple future values. We can go to formulas, and we could search for FV, future value. And this formula builder is a little bit easier way at first when you're doing time value money if you're not so familiar with the formula. So the rate is going to be the rate of return, and per, in this case, will be periods. And then the present value, we put a negative, and then we hit the present value of the initial investment because we're paying this $200 to buy this investment. So it's a cash outflow, and that's why present values are negative. And then we just hit done, and we get the future value amount. Now, it's very easy just to go like this and get all the future value amounts. That's what's great about Excel. If I was just to do it this example, you would see that it would be the same thing, but here I'm going to line B, line 2, 8% rate, and per 7, present value negative 4,500, and then I would hit done. So you see I get the same amount on that. Okay, so let's move into present value here. So this works in a similar way where I'm going to do, instead of FV, I'm going to do PV, get my present value. My rate for A would be 12%. It's a discount rate. And per would be the number of years. And then the future value would be the future sum here. And this is going to result in the present value. And the present value is going to be initially displayed as a negative. So I'll just show you what that looks like. It's going to come in as a negative as a present value. Now, one way to fix this is at the beginning of it, you can put just a negative sign here, and I'll convert it to positive. So if we pull that down here. So let me do another one. And again, I'll close the formula builder. Let me put a 0 here. Okay, so we use the formula builder, and the rate for B would be 8%, and per 12. Payment is 0. There's no payment. You can leave it blank or 0. I prefer to leave it blank. Future value is going to be the 28,000. And then I'm going to hit done, and we get that negative response. But I usually just like to put a negative up here because it's really not a negative present value. It's just the way the Excel calculates. It likes to always display present values as a negative because it's a cash outflow. But really, it isn't negative. This is the actual present value. So if this is the future value of this investment, this is what it's worth today. So I wouldn't pay anything more than $4,448 for this investment because that's what it's worth in today's dollars. Okay, so this is the review of most of the quantitative elements of Chapter 4. I hope you found this useful, and I'll talk to you again soon. Thank you.